Hello and welcome to another tutorial. So this time around we are going to be taking a look at how in Unity we can actually read in audio from the microphone, and also then how to do a little bit of stuff with that in terms of taking that clip that we've recorded and displaying like a little bit of a waveform showing the volume essentially of it throughout that clip. So let's dive on in. So I've already got a basic project set up. It's just a standard empty project. What I'm going to do is I've already got this sample scene that we have by default. I'm just going to call this a demo scene and load that up. And I'm going to set up a folder for our scripts, because there's a couple of scripts that we're going to actually have for this, and I want to get all of those sort of set up in one go. So a few different things that I'll have in terms of scripts. Well, one thing I want to do is I want to have a script that's going to be for displaying the actual audio clip that we have recorded. So we're going to have an audio clip display. Then alongside that, I want to have my actual setup for doing the recording. So I'm going to have an audio recorder. And because we're going to have UI for this, I'm going to set up just sort of a script that's essentially our UI helper. So we're going to have an audio UI helper. So a couple of scripts there that we need that will get us up and running. A couple of other things I'm going to do. It's not strictly necessary, but I'm going to just change the background to a solid color. Just makes it a little bit easier for the UI that I'm going to set up. And I do have a few bits of UI. So what I'm going to do is I'm going to go down to UI, and the first thing I'm going to add in is going to be a raw image. So the way I'm going to do the actual drawing of the audio clip is we're going to have a raw image, which gives us a texture that we can write to. And then with that texture, I'm going to draw on it to actually indicate essentially the intensity at over time during that clip. So I'll create a raw image here. So this is my audio clip display, and I'm going to give that script here, so it's got that already attached. Now I'm going to just configure my canvas. I'm going to use my normal approach, which is scale with screen size, and set it to, I usually use the reference resolution of 1920 by 1080. Now the display for the clip, I want to increase the size of that, so I'm going to double the height, and I'm going to make the width something more like 800, I think is more about right, maybe even a bit longer again. So okay, that'll be the display. Then I'm going to just have a game object for the recorder. So that's not going to have any logic, anything like that yet, but it will have our audio recorder script. And then I'm going to create a panel, and this is going to be my audio controls. So we set up a UI panel, and this is our audio controls. And I'm just going to adjust the positioning of this so that it is positioned, not that height. 100 is enough. And we will position it just at the very bottom like that. So that's good. That will get our UI helper script attached to it. Now, in terms of the controls, well, there's a couple of ones that we want to have. We're obviously going to need a button for starting and stopping recording. We also, often on a computer, may have multiple audio devices, so I want to be able to select which one to record from. And then when we're recording audio, one of the common settings is the sample rate for it. So I want to be able to configure that too. So what I'm going to do is within this, I'm going to create 3 panels. So I'm going to have my start stop. I'm going to have my sample rate, source, and the sample rate. And I'll just set up here to lay this out neatly, a horizontal layout group. We'll just define some padding for all of these, as well as spacing, and let it control all of the sizings. That just makes it nice and easy for being able to have these regularly spaced. And while not necessary, I'm just going to turn off that background image. Again, just making it a little bit cleaner in terms of the setup. So we need to create a button here for start and stop. We import the Text Mesh Pro Essentials. So this is going to be our start stop button. Set up the text for that as well. So this is one where we will actually change the text when it's actually running. So we start recording. We'll up the size on these to something a little bit more reasonable, as well as improving the color there and make our button larger. That's good. So start recording one. So under our source, we need to be able to select the different things. So I'm going to have a drop down here. So we'll have that. So this is our source drop down. So this is where we'll select the particular microphone that we are reading from, and we can update our text to stand out a little bit more clearly. Going to up the size of these as well. So there's a little bit of UI setup that we have to do. Now, if you were just directly wanting to jump straight into doing the reporting in your project, there are chapter entries that are set up for this video, so you can always jump ahead to that if you wish. So that looks good. Make this span most of the area. So we'll do similar to what we've done with these others. I will leave a little bit more space up the top for this one. The reason being is I want to also add in a little bit of text so that we can actually see that this is the audio source. And just align that up to the top. Almost done. That's good. I will center that. I think will be a little bit cleaner. So that's good. Source drop down. Now I'm actually going to use those exact same ones so I can copy and paste them into my sample rate one. Now it does get a little bit messed up with the positioning, but that's okay because I can go and copy stuff from the components and I can paste it back over here. And then that will fix these. So that's sample rate. So that's good. And I just need to fix up the label as well so that it is displaying correctly. Copy that, and we will paste the values and just update the text. Okay, so that's all of our key bits of UI hooked up. We actually can now start setting up the key bits of code for this. So I'm going to open up all of these different ones. Now, some of these are actually really quite straightforward in terms of what they need to do. The recorder itself is actually really quite straightforward. So I'm going to do it first because there's so little to it. So a couple of things. I'm going to have a serialize field because one of the things that we need to do when we're recording one is we need to provide a duration. And this functions as a maximum duration. So I'm going to have max duration, and this is in seconds. Then the other thing that I want to have is once a recording's done, I want to have essentially an event that fires off with it. So I'm going to have a serialize field and a unity event that passes through an audio clip. And this is going to be on recording ready. That. So that's good. I want to be able to check externally if something's recording. So I'm going to have a public bool is recording. And we'll make that a property, and that will default to false. I need a temporary location essentially to hold the clip. So this will be our current recording. And because the way the devices work, we identify a device using the name of it. So that's held as a string. So I'm going to have a string here for the current device. So that's good. Now in our start and update, I don't actually need either of those currently. But what I do need is I need some methods for kicking off the recording. So I'm going to have a public, and I'm going to make this a bool because it could fail to start recording. So I'm going to have a public bool, and it will be start recording. Now, when we want to kick off a recording, we need to, at a minimum, give a device, and we need a sample rate. Now, there are other options that we are going to provide some specific defaults for, but in terms of external interfaces for this, I want to make it simpler for the other code, and it's just the device and the sample rate to actually use. So we have our sample rate. So that's good. So, well, if we are already recording, I need to return false because we don't want to start a recording while we are in the middle of one already. Then I can actually kick off the recording. So I'd say current recording is equal to, and we can go microphone start. We give it the device name. We are not wanting to loop and wrap around. We do have our max duration, and we have our sample rate or frequency. So that's good. Now we can set our current device, because we need to, when we're stopping the recording, we need to tell it what device we're stopping it on. So that's good. And we can say that we are currently recording. However, this could have actually failed. So I'm going to check here. If current recording is null, then I return false, because if this fails to start for whatever reason, this will come back as null, in which case we don't want to set up any of the rest of this stuff because we aren't actually recording. And then otherwise, I can safely return true. So that's good. Now, stopping recording is similar. Again, I want to support that being able to fail. So we'll have stop recording. There's no parameters we need because we've tracked the device and things like that. So what I'm going to do is, okay, well, if we're not currently recording, then I'm going to return false because we can't stop it if we already have stopped. I think it also makes sense that if we're trying to stop, but the current recording is null, or if for some reason our current device is null, neither of those should happen, but just being extra safe with this. So if either of those are the case, we can return false. Otherwise, what we then do is we can say, hey, microphone end. So it will stop doing the actual recording. We need to give it the current device. Now end has no return value, so there's nothing for us to manually check additional to what we're already checking. We can set our recording flag off, and our recording ready, we can invoke that with that clip, and we'll return true. So that is all we need specifically just to do the recording itself. There's more work that we need to do then actually for setting up things like our UI, because our UI needs a few different things. We need to populate that list of devices. We need to populate the list of sample rates, which those sample rates could vary depending upon the device. So we've got to get those parts set up. So what we need to do first here, though, is I need to make a few fields that we can access. So one is going to be for our button. So this is for our start-stop button. I also want to have access to the start-stop button's text. Now that is going to be a text macro GUI. So that's our start-stop button text. That way we can update that text when we are recording, things like that. I need my drop-down. So that's a TMP drop-down. So this is our, call this our device drop-down, source drop-down, either is accurate. I might go for source drop-down or source picker. That's probably a better term. We also will have one for the sample rate picker, like that. So that's good. Now, that sample rate, when we actually query the audio device, we get back two potential sample rates, a min and a max, but we might have other ones that we want to provide as potential options. So I'm also going to have a list here of integers, and this is going to be candidate sample rates. They won't necessarily be used, but it's there as possible ones. So I have candidate sample rates, and what I'm also going to do, because it will be helpful to have, is I'm going to allow us to directly link this to our audio recorder. So that's good. I'll link all of those up to begin with, just so that we have everything properly connected. So our start-stop button, its text gets linked up separately. Source drop-down, sample rate drop-down, that was not the right one. Sample rate drop-down, and our audio recorder. And candidate sample rate wise, a common one is 44,100. So we've got that set up, so that's good. So with those bits, we can start to populate some things. So first thing I need to do is I need to build up my list of known devices. So I'm going to maintain here a list of known devices. I'm also going to maintain, because for each device we'll have a different set of sample rates. So I'm going to also maintain a list that goes from a dictionary to a list of strings, and this is going to be our sample rate lookup. That works. And that one, I can new the known devices. I should actually be able to new that as well. Because what I'll do is in start, I should be able to go, hey, known devices, add a range, and then I can actually just go microphone dot devices, because the microphone maintains a list of strings on it that is just the device names that we need. So that's good. So I might put this into its own setup function, just because handy to have that organized. So setup UI, void setup UI. So, okay, we populate our list of known devices. Well, one possible scenario is that that's empty. So if that's empty, there'll be no further setup that we need to do. But we also, our start-stop button, we should turn that off. Our source picker, we should turn that off. And our sample rate one. Because if we have no devices, there is nothing we can do. So no input devices, or no microphones present. So this would be the kind of scenario where you would want to show an error to the user in that case, because that means that it's either something going wrong with the hardware or the software, but it's not managing to pick anything up. So then what I can do is build up the device info. So I can loop through device in our known devices. So everything we do working with the microphone is via this device name. So first thing I want to do is we'll have this min frequency and max frequency. And I can say, hey, microphone, get the device caps, which is get device capabilities. Here's the device name, and then here's those input and output ones. So that's good. Then I want to turn that into something I can populate into the UI. So what I'm going to do is have a list of integers for sample rates. We knew that. I can automatically add in min frequency, because that is always going to be valid. But then I want to look at adding in these additional ones that I had of the candidate sample rates. So what I'm going to do is for each the candidate rate in candidate ones. So there's a couple of things that could mean that I would not want to include this. So if the candidate rate is less than the min frequency, or if it's greater than the max, then that's actually out of our range, so we don't want to add it. So if either of those are true, then we skip. We also don't want to add it if it's actually already present. So if sample rates contains that candidate one already, then we also skip. Otherwise, we can add that in. So add in candidates after checking validity. So we need to make sure they're valid first. Then our max sample rate. We want to add that in. But again, it could have been in our candidate set of ones. So I only want to add that in if our sample rates, we check if that max frequency is already present. And if it is not, then I add it in. So the reason I check that is it's not unusual for it to come back, and when you get the device capabilities, that the min and max will be the same. So we don't want to add in duplicates. That's not really a good idea. So, okay, that's good. Just to make sure everything's in order, I'm going to sort them, and then I'm going to turn those into a list of strings. So this is the sample rate strings. And that looks good so far. So we knew that. We loop through, and this is actually sample rate in our sample rates list that we put together. All we need to do, sample rate strings, add sample rate to string. So that's good. That builds our list of strings. So build string list version of the rates. So that'll be good. We've got that as a set of strings. And the whole reason for doing all of that is so that what I can do is then our sample rate lookup for our device name is equal to our sample rate strings like that. So a little bit of work involved with that, but we now have our device names populated. We have the sample rates that each device can do all properly there. So that's good. Then I can update the UI. So we know we've definitely got devices because we already did a check here for if the device count was invalid. But what if somehow we ended up with no sample rates for the default device that we would be going with, so the first one that we found? So I do want to check that. So I'm going to check, okay, well, sample rate lookup, and I want to look up our known devices, that very first one. And so I'm just checking, okay, is that count 0? It's very unlikely that it would be, but on the off chance that it is, then what I'm going to do is turn off our controls here, like that. Now that looks good, so we won't be able to start recording. I will enable the source picker still, I just won't enable the sample rate picker. So that's good. Now, if we get past that point, that actually means we fully have everything we need in terms of our devices, our sample rates, and we can actually set this to a default entry. So my source picker, I'm going to clear the options. Then I'm going to add in, and I can just add in my known devices like that. And I will tell it to set value without notify, and just to the first one. I do similarly for the sample rate picker, where I clear, I add in options. Now in this case, what I add in is the sample rate lookup, and I add in known devices 0, like that. And again, I do the same setting of the first index. And I do without notify because I just want it to directly switch to it. I don't want to have it kick off any other logic. So that's good. That should populate our lists. And we can actually test to see if that works. So we can see it's got my different devices here. There is only one sample rate that comes back at the moment, but that's okay. So as a result, it's not going to be able to add in any custom ones because there's not an actual min and max range. It's just a locked frequency that it's able to come back at. So, okay, that's good. What I want to do then is get stuff going for, okay, well, what if we select a different source? We need to rerun the logic and check, okay, do we have sample rates that can be selected? So what I'm going to have is a public void on source selected. Now we get a index in as part of that. So that's good. So what I would do is my sample rate picker, I would clear my options. I would then check for this particular device that I will have selected, the source, do I actually have samples there? So, okay, I can check sample rate lookup for known devices at that index. If that count is 0, then we turn things off. That. Otherwise, we can actually turn things back on. And I will be able to populate the options. So I can say, hey, sample rate picker, add options. I can just give it that same thing I was checking before here. Oops. That. And I would say sample rate, and I would tell it to set value without notify to the first entry. So anytime we select a source, it will just go and update things there, which is good. And we won't actually see anything different for when we're working with it because all of my devices actually have the same sample rate. So it makes it very difficult to actually illustrate the difference between them, but this at least gives us a setup where it can work for it. So then the other thing I need is obviously linking up our button for doing the recording. So I'm going to have on start stop button clicked, and this needs to figure out what it should actually do. So, well, okay, with my linked recorder, I can ask it if it's already recording. If it is, then I update my start stop button text, and that returns back to being start recording. The reason for that is what I would do is I'd say, hey, linked recorder, stop recording. So that's good. Can reset that text. What I would also do is while it's actually recording, I'm going to turn off things like our pickers. So I can restore our source picker, go back to being enabled, and our sample rate picker will also go back to being enabled. And the reason for that is, as I said, when I get here, so if it's not currently recording and we're actually starting it, then these are going to change so that we turn those off like that. That will be stop recording. And then what I also have to do is say, hey, linked recorder, I want you to start recording. And I want to be able to give it the device and the particular sample rate. So I'm going to have, and don't have properties for this yet, but I'm going to have one that is selected device, selected sample rate. That. I'll set these up here. So what we'll have is, and these won't be external yet because I don't think there's a need to, but we'll have a selected device, and that will be known devices, source picker value. So we use that for figuring that out. Then we have our selected sample rate, which what that's going to do is we'll go for our sample rate lookup. We use our selected device, and then within that, what we want to grab is our sample rate picker dot value. Now that's giving us a string, so I can do an int dot parse, and that will get me that string converted back to an integer. So that's all we need in terms of our UI helpers. So we can link up a few of these things now. So a couple of things we need to link up. For our source dropdown, we need to connect up so that that goes to talk to audio controls when that's changed. And we have our audio UI helper on source selected. Our start stop button, when it gets clicked, we also want to relay that through. So that's going to go to audio helper, and we should have, yep, our on start stop button clicked. So that's good. We've got things connected up in terms of our UI should be functional, and I should find then, while nothing will be happening with it, I should be able to go start recording, and that goes to stop, and I can't change the source. But then when I stop recording, I'm able to modify this again. So just avoids people potentially causing issues there with it. So that's good. Now we can get this audio clip display up and running, which I'm also going to give it an audio source, because after we get the clip, it would be handy to have it that we can then kick off actually playing it. So the audio clip is a little bit more involved in terms of what we need to get set up, but a couple of things that we need to be doing for this. So just from a point of view of making it a little bit visually cleaner and neater, I'm going to have support for, with the clip, a little bit of a margin. So I'll have a horizontal margin, and that's going to, we'll default that to 5. Now the other thing is when we record a clip, with my setup here, what I will get back is a mono clip, so it will be a single sound channel, but you could get back multiple sound channels. You could get back something that's a stereo one. So what I'm going to also do is have support for essentially spacing between the channels. So we'll have channel spacing so that we can show that. And the way channels are encoded in this stuff is a little bit unique in terms of how it works. So there's a couple of hoops that we have to jump through for this. So that's good. Now I'm going to have a require component and our raw image. I'm also going to do that with our audio source, just because I want to make sure those are present. So because I'm requiring those components, I do have a nice ease of setup here in terms of, okay, well, I want my raw image, linked image. I also want to have here our audio source, the linked source. Now I said I was going to be putting together a texture that was going to be displaying the actual audio. So I want to set that up. straight parentheses there. So that's, oh wait, no, that one's fine. This one was missing one. There we go. So I need to have a texture. So I'm going to have here a texture 2D, and this is going to be, we'll call this display texture, I think is a suitable name for it. So that's good. Then in Awake, I want to make sure I populate things like my linked image and the linked source. So the linked image, that's good. And we do similar for the source. So we've got those stored, which is great. Then in Start, what I want to do is I want that texture to match the size of what the UI image is, or that raw image is. So what I'm going to do is I'm going to get my image dimensions, and I do this by I make use of this rect transform utility, and I do pixel adjust rect. I give it the linked images rect transform, and I go linked image canvas. That makes it easy for me to know our image width and height then. And I'm just going to store those. So I'll have image width and image height like that. And how I populate those is our image width. We can do a mathf, and I'm going to do that as a ceil to int. So I want it to round up. So we get the width like that. We do a similar thing with height. So that's good. That gives me the width and height of my image in pixels, which means I can then create that texture. So our display texture, that is a new texture 2D. We provide the width, we provide the height, and the rest of the defaults autocomplete was wanting to populate there, which is good. I'm going to turn off wrapping because I don't want that in this case. And then my linked image, I can just connect up the texture like that. So that's good. I've got that populated, which is what I want. Now we get to kind of the nitty-gritty of it, of being able to draw this, because the way the data is organized is a little bit complex. So first thing, going to have a function here, on set new audio clip. So this will take in new clip. So we can retrieve data from this, and what we retrieve is the intensity of the samples. So what I'm going to do here is going to go and say the size. Now the size is actually the number of samples in the clip multiplied by the number of channels. So how it works for something like a stereo audio clip is the sound is organized, and it will be first channel, then second channel will be next to each other for the first sample, and then it repeats that pattern. So the channel data is interleaved there. So we need to be doing a little bit more in the way of steps for actually iterating through that data. The other thing is if we go and say record a 30-second clip, we're going to have a huge amount of samples, like absolutely huge amount of samples. So we need to coalesce blocks of those samples down into something where we can meaningfully draw it. So what we'll find is we'll probably need to be coalescing something in the vicinity of a couple of thousand samples into an individual pixel. So that's going to be stuff that we're needing to set up here to be able to meaningfully draw this. But first step is I get the size like that. Then what I do is I want to try and retrieve that data. So clip data. Now I can new that. So that's a new float of size. Oops, that. So that's good. Then what I do is I attempt to retrieve it. So I go and say, okay, well, in new clip, get data. We give it our clip data array that we're wanting to output to, and we have no offset for it. If that fails, oops, then we just return immediately. So if we can't retrieve the data, there's nothing further to do. So attempt to retrieve the clip data. So that's good. Then I need to, because the contents that we might have for the clip have changed, I need to figure out some of the things for being able to position stuff. So, okay, firstly I need to figure out the sort of size and heights to be able to be working with that. So figure out current UI heights. So I need to do this by, firstly I'll work out my total vertical padding, which is going to be my channel spacing multiplied by however many channels we have plus 1. So the channels plus 1. The reason there's the plus 1 there is because, okay, we might get that there is one channel, but I want to pad it evenly top and bottom. I want that channel spacing applied at the top and bottom for positioning this. So we always add 1 to it. So that's good. Then I can figure out my height per channel, which is going to be my image height minus the total vertical padding divided by the number of channels that we have. Now, while it's very unlikely, but just in case our height per channel is somehow 0, we will return. So we'll just exit out if that happens. It's very unlikely that it would ever happen, but we just want to be a little bit extra cautious with it, just to make sure. So, okay, that's good. Then what I can do is I can start to figure out things like, okay, well, what is my horizontal area that I've got to draw in? So my working width, well, that's my image width minus 2 times the margin, or the horizontal margin. So that's good. Then I need to figure out how many samples will correspond to an individual pixel. So how I can figure that out, so my samples per pixel, well, I know the number of samples that I have, and I know the number of pixels that I have. So I can just divide like that. Now, given our sample rates for clips are generally in the order of tens of thousands, and our width is very likely not going to be that unless you have a scarily gigantic monitor setup. So this should be something that it's a safe setup, but just in case, say we got a scenario where the samples per pixel was somehow 0, we'll bail out. Highly unlikely to ever happen. Something would need to go pretty wrong for that to happen, but just in case, we'll make sure we've got a check there for it. So that's good. What I also want to be able to do is when we're drawing the samples, I want to kind of scale things to fit the area so that we're taking up the full space. So figure out the bounds. Now you might not necessarily want this, especially if you're showing multiple clips. You might want to have fixed bounds, but I want to have dynamic ones for this. If you were having fixed ones, you could just omit this particular code. So what I would do is have float min value, which we default to float dot max value. And we do similar for the max, but we default it to the min. Then I'm going to traverse all of my samples like that. And what I'm going to do is convert that sample first. So working sample. So we do a mathf absolute value of the sample. Then, okay, well, if that working sample is less than the min value, then we update it. If the working sample is greater than the max value, then we update the max. So that's good. We've figured out the bounds for the data that we have. Now we need to process the actual data for doing the drawing. So, okay, what we have to do with that is I'm going to process it one channel at a time, because I think that will be a little bit easier for working with. So we process by channel. So we have our channel index is 0. Our channel index is less than the number of channels in that clip. So that's good. So we process each channel at a time. So channels will have a particular vertical offset. So that's useful for us to actually store now. So we'll have our channel Y offset. And what that will be is we want to offset our spacing, so that vertical padding. So we'll have our channel spacing, plus with each index, we offset a little bit further as well. So we're going to then have plus our channel index multiplied, and what we do is it gets multiplied by our channel spacing plus our height per channel. That actually could fit on one line. That's fine. So it gives us our Y offset for the channel. Then we're going to loop through all of the pixels in this graph. So loop through the horizontal axes. So this is our X index, our index X, which will be 0. Actually, I might call this pixel X, graph X, actually. That's a better one for it. So that starts at 0. Our graph X is less than our working width, so not our image width, but our working width, and we increment it. So, okay, that's good. We need to somehow turn all of that into a actual sample index though. And we also, this one pixel is going to correspond to multiple samples that we need to average together. So what I'm going to do is loop through the samples for this pixel. So 4. And what we're looping through here is our local sample index is 0. Our local sample index has to be less than samples per pixel. And we increment it like that. So the outcome of doing this looping here is we get an average. So I'm going to set up here sample sum, sample count, and we'll call that local just to keep it consistent. So, okay, that's good. We need to figure out then, okay, let's increment our local sample count. That's easy. But to increment the local sample sum, or to update it, we need to figure out where we actually are reading from. So this is a little bit more complicated for figuring that out, because we know things are interleaved, so the channel data is interleaved. So for sample 0, we'll have channel 0, channel 1, 2, however many there were, and sample 1, it would be those channels again in order. So we need to figure out, firstly, our sample index. That will make it this easiest. So our actual sample index is going to be our local sample index plus what we add to that is that graph x, and that gets multiplied by our samples per pixel. That's good. I'm going to rename this just so I'm using consistent terminology with these. So this is our index like that. So that's good. So, okay, we have our sample index, and then because that's our sort of base location for the sample, we need to figure out the actual one for the particular channel. So we'll have our actual data index. Oops. So our data index is our channel index plus our sample index multiplied by the number of channels that we have. So that gives us our actual data index. Now, while it's unlikely, because we were kind of looping through pixels and the sizing of stuff, we could end up with a data index that is out of range. So if that data index is greater than or equal to our clip data length, then we just do a break. Otherwise, our local sample sum, we add to that our mathf absolute of clip data and data index. So there's a lot of bits to jump through for that, for reading it. It is quite a complicated way of reading it because of the fact that we have potentially multi-channel data there, and because we need to remap things to something that's significantly smaller in terms of the amount of data we can show. So it does complicate things a little bit there. But once we've got that, well, if the sample count, for whatever reason, is 0, there's nothing to do. Unlikely to happen, but good to check just from a safety point of view. But then we can get our averaged value. So our averaged value is going to be our local sample sum divided by the count. Straightforward. We can then normalize that. Value, which nice easy way that we've got of doing that is we can use an inverse lerp. We give it our min value and our max and that averaged one. So that's why if we did want to turn off that sort of auto ranging, which is effectively what this is, if we wanted to turn that off, all we would need to do here is our normalized value, we would just change that to be, for example, equal to our averaged value. So we wouldn't do this scaling with min and max. So that's good. We've got that normalized. What I can then figure out is our actual position to draw at. So our Y position, well, that's our channel Y offset plus our normalized value multiplied by our height per channel. Now, this is going to give us back a float, whereas this is an int, and we want to store it in an int. So I can do a mathf, and I'll do a round to int for this. We want to bring it to whatever's roughly the closest one. So with that information, I can now draw this, but what I need to do, because I put these outside of the loop, these need to go inside here, and so too does this. Otherwise, we'd be calculating it over all the wrong data. So, okay, we've moved those back so they're in the correct spot. Then I would say display texture, set pixel, and it's my horizontal margin plus my graphics. I have my Y pos that I've calculated, and I'm just going to draw a black pixel for it. Be nice and clear. So that's good. What I can then do afterwards to apply that is I say, hey, display texture, apply. And I'm also then going to, if it passed all of this, I'm going to say, hey, linked source, my clip is this new one. And what I also want you to do is I want you to play that one that's actually come back. So that's good. We're pretty much done with this. The one thing we haven't done is made sure that if we recorded multiple ones, we need to clear the current drawing. So what I'm going to do, and I'll do this regardless, is I'll have a image pixels is a new color that we loop through all of those. We have our pixel index 0. Pixel index is less than image pixels length. Just going to set the color of all of these. It's set to white. And then my working, or my display texture, I can just go and say set pixels with that. It just clears the image. So that's good. That should be really everything I need for actually making this work. I just need to link up things like our thing here for when the audio recorder is finished. That has to talk to our audio clip display. So that audio clip display and our onset new audio clip function. And then if we just double check that everything else is linked up, which it looks like it is, and our display is all good. So we should be able to test this out. So let's try it. So run it. So I can select the microphone I'm currently using. And then if I go and do start recording, at this point in time, it should be recording the audio from me, from what I'm saying, through this actual microphone. And then when I do stop recording like this, then we can see the graph is shown here. So we've got the graph shown here. Now, while we wouldn't have likely heard the audio for where it was when it finished there, that's just because of my recording settings. It did actually play. And if I zoom in, because we're just drawing a single pixel for each one, we can see the individual pixels for the waveform there of what it actually encountered. And I could make that so it's a little bit more obvious what's actually happening if I wanted to. So one of the options of what I could do for this in my audio clip display is what I could do is for and an int here, and we'll have y pause. Actually, we'll have y, yeah, we'll do y pause. We'll change this so that this is actually y end. And we loop through from y pause needs to start at my channel y offset, and it goes until it is less than or equal to y end. And we just draw a solid line. So this should give us something that's a little bit more obvious. So if I run with that, and so I can do a little bit of recording while it's actually doing this, and then if I stop, then we get something that's a little bit more familiar for what we'd expect to see with this by us drawing those particular lines there. Now, because we've set the audio clip length to 30 seconds, that does mean we get this empty section at the end of it. That's something that is not necessarily always going to be the easiest to trim. The reason being is that you need to have a good detection for periods that are quiet. That's not something I'm going to dive into for this. So with that, we can try and see, okay, well, what if I do another recording over the top of this? So now in this case, it's doing another recording, and I'm going to intentionally make this a longer recording because what we should then see is different data that appears on the actual display there. So I can stop it now, and we have that very different waveform. So it's correctly updating. We can see the waveforms nicely being shown there. So we've got a system where we can be getting clips in, we can be showing them, we can be playing them. We do have this dead zone here at the end, which that's something where, because when you say that it's recording for 30 seconds, it gives you back a 30-second clip regardless. So we would need to do some form of trimming there for that, but your needs there are going to be very dependent upon the particular setup that you might be working with. But we've got a basic thing that we could be using here now in different games. So dive on in and experiment with this and see what kind of things you can do with it, see what things you might want to add or how it might fit for projects of your own. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, the code is available up on GitHub, and there is a link to that in the description below. You can use that code in any of your own projects, commercial and non-commercial ones. If you have any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon and YouTube Super Thanks for enabled as well. But until next time, bye.